So last class what we were seeing, we solved some problems in a class. We trained a problem we solved. So basically this problem what we are trying to do was crane load and support load load. What is the equivalent load here, or more or less what is the reaction or support load coming? Load on the ground load. Okay. So this is also similar to equivalent load concept. This load is not transfer. So similar then what we found is resultant of forces. Every body multiple forces forces. Okay, we can actually find the resultant. We can change or represent all these forces with one force, single force, like this. But single force represent here. So the idea is whatever is happening to the body because of the forces. If forces are in the body, same thing will happen when we apply this force. Okay. Now this force is the pass in the point bisect in the force. So basically equivalent force in this line. We can find equivalent force in any line. Any line force. Okay. If I ask you if this force, instead of this force, if force pass in the horizontal line, and it's a very vertical line. There is some force in this vertical line which will also give the same action due to this force. Okay, so it is equivalent resultant force. Angle. Only thing is force of magnitude and the orientation of the variable. Okay, so that concept you should understand. You should do a lot of problems with this with respect to this. When an assignment another problem. Okay, then we started about simply supported beam. And that is simply supported beam. Simply supported beam is basically an object. So let's say I have an object like this. Okay. Support two supports. So this is what I call as support. Support in the garden and the beam in a support and they supports on. Supports. Okay. Apply support that means I will apply some force. Okay. Force basically what happened, the force is acted on this. Force is it is supposed to move down. Force here body apply out to but she is supporting and introduce stable. Okay. So when I am applying some force in this direction, this support is actually giving some other force in the opposite direction. Okay. Upper summation of all the forces in y equal to 0. That is stable now. Okay. What I was seeing is if you see this so let's say is a weight. Let's say somebody is standing on this stone. Okay. Now is it going down? It is not going down. It will not go down because okay. And so the weight of this stone is acting downward. The weight of the person who will be standing here also will be acting downward. Okay. So let's say first person here. Okay. So weight of the stone will be acting down. Weight of the person also will be acting down. But stone isolated. There is a weight of the stone here. There is a weight of the person here. So, in the y directional equilibrium forces in y direction should be equal to 0. If equal to 0, equilibrium it is acted by an unbalanced force. So it is supposed to accelerate down. So it will not happen. There is some contact here. Okay, so the whatever stone is here, it is actually giving what is known as a reaction. If force in opposite type of reaction. This also is giving some reaction. Now, this reaction, this force equal it is not moving downward. Okay, so that is the idea. So this kind of arrangement is what is known as a simply supported beam. I mean, beams practically we are using it. That is why we are supposed to find this. Why are we finding this? There are many reasons. Let's say the weight of this is not a person. There is a lot of huge weight here. Weight into that. So if this stone is not able to give that much reaction, After reaction is stone, it will break and come down. Okay, so we have to see what is the force coming on this stone. This stone is strong so that it will stay in the place. Okay, so force evaluate. We have to find this. Now we will elaborate more on this. So we also found pinned roller and support condition. Okay, support condition support condition is depending upon the reaction it is given. എത്ര തരത്തിലുള്ള reaction support കൊടുക്കാനനുസരിച്ചാണ് support condition. Okay, so one is a pinned, other is a roller. So pinned and roller means pinned എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ so basically it can give two reactions, one vertical reaction, one horizontal reaction. അതായത് ഇവിടെ if I try to push the body in this direction, ഞാൻ ഇങ്ങനെ ഒരു force apply ചെയ്ത് കഴിഞ്ഞാൽ there is a reaction from here. Here stronger. Okay, so that is why this point, if you see this point, this area, it can give two reactions. Okay, so that is why it is a pins. It's a pins. We'll represent this as a pins. So here support actually it is free because there is nothing here. It is free to move. So that is why this support can give only. So this is a force. This is a force. This is a reaction. Okay, this support can give only one reaction. So that is why it is called roller. For roller, in force apply it will give reaction. In force apply it will just move. Okay. So that is the condition. So we will see more on this. So there is one more support condition that we should know. Fixed. So it is represented like this, fixed. So fixed it will give two reactions like this. Reaction. In addition to this, it can oppose movement. Okay. So for example, if I am holding a scale like this. Okay. Now if I put some force here, what happens is it is not moving down because I am putting a force in the opposite direction here. If I pull it like this, it is not moving because my finger is actually reacting it. If I rotate it like this, it is also not rotating because I am in the opposite direction of movement in the okay. So that is why it is called fixed support. So we will see more on this. So if you are confused, don't worry. I will show you some more examples. Okay, so let's see. This is a bridge. Okay, this is a bridge. You might have seen this kind of bridges, mostly railway. Steel bridge, but there's a lot of bridges in Kerala. Whenever there is a river, we need a bridge. Okay, so bridges are structures like this. So if you observe here, this is one support. Okay, so this is another support. Support. That is bridge and support. This is bridge in the. This is what is known as pier. Okay, this is also what is known as pier. It is resting on it. Resting it is supported on this. Okay, so this is a real case. Number stone wall bridge. People are walking around. Now, what is this support? A support. If you observe this support, I don't know whether it is visible. Okay, you can see this support here. So this support looks something like this. Something like this or this. Okay. Now, if you see there, observe here, E support, you observe this support. But, you forget about these supports. You observe these two supports. So this and this. This support is what is known as a pinned support. This is also pinned. So pinned support. So if you observe this support, connection you may be able to visualize. It can rotate. Free item rotate support. Okay, if I apply a force in this direction, if you apply a force in this direction, or if you apply a force in this direction, force in this direction or in this direction, it will react. But the force applied, it will not go down. Force applied, it will not go that direction. Okay, but it can rotate. So that is why this is pin support. So this support is represented like this. Withdrawn will support we represent like this. Okay, same this. This is also represented like this. So that means this can give a reaction in this direction, can give a reaction in this direction. Okay. Now you see this. This is support 3 angle. So this also can give a reaction. So generally the reaction it is given like this. It has 2 components, the horizontal component and the vertical. So this is also pin. Only thing is it is an angle. So this we will represent as like this. So this is also pin. Now this is what is known as a roller. Roller. So roller in the if I apply a force in vertical direction, it will give a reaction. It will give a reaction. Okay. But if I apply a force in this direction, no reaction in this direction. No reaction because it will just roll. It will just roll. Okay. So that is a roller, and roller is represented like this. It rolls something like this. Okay, it is capable of giving. Now you can see here also there is a roller. Okay. So this is also see, even though it is a slightly different support. There are different wings. Why is it different? What happens is correct shape. It is something like this. Okay. So if this surface is smooth, that means minimum friction. Then it is a roller. Okay. If there is considerable friction, so considerable friction again force apply okay, it will be stopped by friction. Smooth will just slide. Roll around. Considerable friction we'll assume it will be paint. So that depends upon how smooth the surface is. Smooth material it will become. Okay, so generally this is rollers. Suppose the rollers are that depends. Age rust so it cannot move in this direction. So it will become paint. Okay. So this is how different support conditions we actually use in active structures. Okay. Now there is a fixed support condition. We will not learn about that today. So now what happens? For your convenience, generally, instead of that, let's say we will say we have only a small beam or something like this. Remembering the member of the let's say you have a small beam like this. Assume that in a beam. Then we have let's say we have a pier like this. And finally, it can be a riverside or that is pinned here. Currently, people are not putting riverside because very high amount of cost. Right. So this is a schematic. We simplify analyze we just draw as a line. We just draw as a line and supports. Okay. So this is how the support condition works. So this is what is known as a simply support. The names for support is not actually clearly specification, but if you are going to the box. Simple support. Okay, simple support. This pair of support condition simple support. One end it should be pinned. I think that the radius of 2.6 to 2.8 and other end should be roller. Okay. But this combination is simply supported beam. Okay. Now what we have to do is we have to find the reactions. So next task is to how to find the reactions. Find reactions. Support the reactions. This is nothing but support reactions. Support. Support reactions. Okay, he support the reactions. That is, we in the mail. So just maybe copy this. What if then? So let's assume that we are loading this. Let's say we are putting. Let's say there is a person standing on this. Okay. So let's say it's 80 kg person. Okay. 80 kg no rainbow. So 80 kg is equal. 80 kg is the weight of person. Okay. 80 kg. So in force is mass times acceleration. Mass is 80. Acceleration due to gravity, let's say it is 10. So 800 Newton. Okay, 800 Newton is the load. So this I can also represent like this. I can simply represent. $800. Okay, 800 Newton. So let's say the length of the bridge is, let's say, 6 meters. And he is standing at, let's say, 3 meters. So this is 3 meters. And total length is 6 meters. 6 meters. Okay. Now what would be the reaction? The reaction is pinned support. Pinned support can give two reactions. It can give a vertical reaction and can give a horizontal reaction. Okay. Roller can give only one reaction. Okay. This system, if you can see, because of the supports, we have two forces. There is a possibility of two forces due to pin support and the possibility of one force due to a roller support. Okay. Now, what is this value? So let's say we will start giving them some names. So this is A, this is B. Okay. So I'll call this as, let's say, vertical at A. Vertical forces. This is vertical forces B. This is horizontal forces A. Just giving you some names. Okay. But what is the value of HA, VA, VB? This is find magnitude of HA, VA, VB. Okay. So these are what is known as support reactions. Okay. So I hope this is clear. Then the bridge there is a weight acting downward. But since there is a weight acting downward, there is an unbalanced force in the downward direction. So it is supposed to go down. Entire body downward. But what is preventing it? The supports are preventing it. Okay. Now, depending on the type of support, it will give different types of forces. So once it's pin support, it can give two forces. When it's a roller support, it can give one forces. Okay. So forces just assume. Now, what I am trying to see is I want to find the magnitude of the forces. So what I will use this. Even I observe I am observing that the beam is not moving. Okay. This beam is not moving. That's the observation. Our force, our beam, bridge right load to bridge rotating, nothing is happening. Okay. So that means the bridge is in equilibrium. This is another way of telling that it is in equilibrium. Equilibrium equations. Okay, so that means it is in equilibrium. This implies equilibrium. So it is not accelerating in downward direction, right direction, or any direction, or it is not rotating also. So that means it's in equilibrium, complete equilibrium. Okay. So let's try to solve this. Then we solve it. Okay. Okay. So now let's see equilibrium. So what I will do, equilibrium in the sense when I say it is an equilibrium, and equilibrium എന്ന് പറയുമ്പോൾ you can always say all the forces, all the components of forces in x direction should be equal to 0. All the forces, the components of all the forces in y direction should be equal to 0. Movement about any point equal to 0. Means എല്ലാ ഫോഴ്സുകളുടെ movement about any point should be equal to 0. That is about equilibrium. Okay. It is system equilibrium. This is for 2D. 2D system. 3D angle, you have a z direction component also. You have movements in three more directions. Okay, so that will higher right modules. But understand this concept very well. Equilibrium എല്ലാ ഫോഴ്സുകളുടെയും x direction ഉള്ള കോമ്പണന്റിന്റെ സം 0 ആയിരിക്കും. അതായത് ഈ ബോഡിയിൽ when a body is in equilibrium, all the forces in x direction, all the forces acting on the body in x direction, or the components of all the forces in the body, the x direction should be equal to 0. Components എന്ന് പറയാൻ കാരണം ഈ ഫോഴ്സ് ചിലപ്പോൾ ഇങ്ങനെ ആയിരിക്കും ആക്ട് ചെയ്യുന്നത്. Okay, so that also is possibility, right? So let's say okay, now let's say how do you find that? So what is summation of all the forces in x direction? X direction. So let's say right is positive. So this is a convention that we are going to use. Okay, right is positive. So summation of forces in x direction should be equal to 0. This is equilibrium condition 1. So that means what is force? HA is there. HA is there. There is no other horizontal force. So HA equal to 0. So we got 1 plus 1. So there is no horizontal reaction in the support because for equilibrium, this force on for support it is giving only one force. Now, summation of all the forces. Summation of all the forces in y should be up is positive. Okay, so what y direction of the force? So that implies I have a minus 800 here. Minus 800 here. I have a VA here. Plus VA here. I have a VB here. Okay, so any other force? No other force should be equal to 0. Okay, so this gives me VA plus VB equal to 800. So it makes sense. It makes sense because താഴോട്ട് എത്ര ഫോഴ്സ് ഉണ്ട് 800. ഈ രണ്ട് ഫോഴ്സും കൂടെ കൂട്ടി same force മേലോട്ട് അപ്ലൈ ചെയ്യണം. Okay, so it makes sense. VA plus VB is equal to 800. So this is coming from my equilibrium equation, right? Now, summation of moment about any point should be equal to 0. So I'll take one support. I'll take A. You can take B also. Nothing much. There is no problem here. You can take any point also. Okay, but there is an interesting why I am taking support. Support in you will observe it now. So summation of moment about A, or I can say summation of moment about B also equal to 0. Any point I can take. I am just taking about A. Okay. So what are the forces about A? So there is an HA here, but it is passing through A, so it is anti-clockwise is positive. Okay. There is a VA here. The distance is again 0. അതുകൊണ്ടാണ് ഞാൻ ഈ പോയിന്റ് എടുത്തത് because these two forces are passing through this point. Okay. Now there is a VB and there is a distance 6 meters. Okay. So VB into 6 meters, it is rotating in anti-clockwise direction. It is plus. Okay. Is there any other force? One force, second force, third force. There is one more force, 800. So there is 800 times 3 meters. It is trying to rotate in clockwise direction. About support A and moment. So when I see this support, I am holding this support. It is trying to rotate in clockwise direction. So that this should be. Okay. But imagine that your hand is here. this is 0, this is 0. Now this about this point, the force on the moment is trying to rotate for anti-clockwise direction. So that is why VB into 6. E force on 600 into 3 is the moment about K and is trying to rotate in clockwise direction. So that is what it is. Okay. So this is 0, this is 0, 6 VB. So this is equal to 0. 6 VB minus 2400 0. And if I use regression circuit, okay, that means VB equal to 2400 divided by 6 equal to 400. So this is right. Now what I will do, I will substitute this 400 in this. This 400 I will substitute in this and I will get what I will get. VB plus 400 equal to 800. So that means VB equal to 800. Sorry, VA. VA equal to 400. Right? VB is equal to 400, VA equal to 400. Then HA equal to 0. Up and the final forces get. So I can draw that. And I'll finish my answer. Okay, so this is VA, this is 400. This is 0. This is HA. There is a force in this direction. VB equal to 400 Newton. And there is a force here. 800. Just give me a moment. Second criteria is graded activities. Okay, sorry. So I hope this is clear. Okay. So observe what we have done. First support condition. Simply support beam support condition. Okay. There could be some changes. So all those changes also we will see what other changes. Before that, let us do another question. Let's try to do another question. Okay. So let's say find the support reactions. So support reactions. So let's say I have a beam like this. I have a pin here, I have a roller here, Let's say this is again 6 meters.
Size 100% very 100% satisfied. First
6 meters.
second is
Let's say I have a force in an angle. Let's say the angle is 30 degrees. Okay. Force is, let's say 2 kilonewton. 2 kilonewton force at 30 degree angle. Okay. Find the support reaction. Now, how do you solve this? The first thing is you have to observe the support. What are the supports given? For supports in the we know that there is a roller here. So there is a pin support here. And this is a roller support. Roller support. Okay. So pin support can have two reactions. A horizontal reaction, a vertical reaction, a horizontal reaction. Roller can give only one reaction. Okay. So I will I will call this as A. Then call this as B. And let's say this distance also is given 3 meters. 3 meters. Okay. Now this can give two. Pin support under reaction. Roller support with reaction. Right. Now, so let's see. We will again redraw this diagram with forces. So let's say we have a force in this direction. Okay. We also have two reactions. Reaction here, another reaction here, and one reaction in this direction. Okay. So this is my 2 kilonewton. This is my V vertical at A. This is my horizontal at A. This is my vertical at B. Okay. I will mark the distances also. There's a 3 meter here. There's a 6 meter here. Right. Now, the moment I say it is in equilibrium, structure in equilibrium. So equilibrium means summation of all the components of forces in x direction should be equal. Summation of all the forces or the component in y direction should be equal. And summation of moment about any point should be equal. About any point should be equal. Okay. Now, this time we will do something different. Let's say we will find this first one, summation of forces in x direction. Okay. So what is the forces in x direction? X direction and the kind of force. About this 2 kilonewton force, I can convert into two components. Okay. So now, I think yesterday when I was seeing your answers, some people are still confused. Components are okay. So components are there is nothing complex about this. So let's say the force is in this direction. Okay. So imagine from this point to this point you have to travel. So you can travel in many ways. You can travel like this. So that is one. Then you can travel like this. So that is this. That is one way of doing it. Okay. Another way of doing it is another way of doing it is you can travel in this direction. Then you can travel like this. Okay. So vertical force downward, horizontal force okay. I can rub this off this force and force I'll make it dotted. Then I can replace it by two forces. One force would be vertical down. Another force would be horizontal left. Okay. You can use this. This point in the travel in the direction. But ആദ്യം താഴെ left അല്ലെങ്കിൽ ആദ്യം left പിന്നെ താഴെ ഏതായാലും you can see the value. So if the force is in some other direction, let's say the force is in this direction, you can see that, you can observe that first you have to travel in this direction. So that is my horizontal component. Then you have to travel in this direction. That is my vertical component. Okay. So that is how you split the forces into components, or you see the direction of the components. Now what is this component? This is 2. What is the horizontal component? What is the vertical component? Okay, this is theta. This is 2. So this is 2 cos theta. This is 2 sin theta. Cos theta equal to opposite by. So I hope you know this. You just tell me. I'll teach you. Okay. So this is vertical component is 2 sin theta. This is 2 cos theta. Okay. So now I can remove this. So theta is 30 degree. Okay. Now what we'll do? Okay. Summation of force in x direction. What is the force? Or what is the force in x direction? So right is positive. Okay. So we have an HA. It is rightward, so it's positive. We have a 2 cos 30. It is in left side, so this is minus. Okay, it should be equal to 0. Now what is cos 30? Cos 30 is root 3 by 2. So HA equal to 2 into root 3 by 2 equal to root 3 newton. Okay, so that means HA equal to root 3 kilonewton. So not okay. Now summation of forces in y direction should be equal to 0. Up is positive. May not have a positive element. So what are the forces in y up direction? You can see this. There is a VA in upward direction, so it is positive. There is a VB in upward direction, that is also positive. Then there is a 2 sin 30 in downward direction, so that is minus. Okay, so this should be equal to. So this should be equal to. So after all of this, okay, right? So that means VA plus VB. VA plus VB equal to 2 sin 30. So sin 30, I think it is half. Sin 30, just verify that half. 2 times half. So that means VA plus VB equal to 1 kilometer. So there is another equation. Now we will use the third one. So any moment, any point you can take. Any moment you can take. Summation of moment about, let's say, B equal to 0. Anti-clockwise positive. Okay. Summation of moment about B will take anti-clockwise positive. Anti-clockwise positive. About, let's say now B about this point moment about this point. Okay. Now let's see about this point when you have finding moment. So we can see what are the forces. Okay, anti-clockwise positive. So VA times 6. VA times 6, it is anti-clockwise direction. So it is this VA times 6 anti-clockwise, so positive. About B and so VA times 6 anti-clockwise positive. HA into 0, HA times 0. Okay. So these two forces are over. E force 2 sin 30. 2 sin 30 into what is this? This is 3. So 1 second. Sorry for that. Right. So, now we have to find other. HA is passing through this point, line of action. VA into 6, it is in anti-clockwise direction. So, it is in clockwise direction. So, sorry. It's clockwise direction, so it should be minus. VA into distance 6 is anti-clockwise direction, so it's minus. Okay. HA into 0. Then we have 2 sine 30 into this distance is 3. Okay. 2 sine 30 times. It's better if I write here. 2 sine 30 is 2 into half equal to 1. This is root 3. So 2 sine 30 into 3. It is in anti-clockwise direction. Times 3. It is in anti-clockwise direction. Then 2 cos 30 into 0. Because it is passing through this point. Then VB into 0. So summation of all the forces should be equal to 0 about any point. That's only B. You can take this point also. Okay, either point or you can take another point 1 meter here also. Any point you can take because equilibrium in the condition. So let's say what all is losing. So there is a 6 VA minus 6 VA here. So minus 6 VA here. This is 1. 2 sine 30 plus 2 sine 30 is 2 into half into 3. Okay. This is 0. This is 0. So this is 3. 6 VA equal to 3. Okay. So I'll take 6 VA this side. So this is basically minus 6 VA plus 3 equal to 0. Okay. So that implies 6 VA equal to 3. VA is half. VA equal to half. So vertical force at A half Newton. Now what we will do? We will substitute here. E equation of substitute. Then what will we get? VA plus VB is equal to 1 kilonewton. So that means half plus VB equal to 1. So VB is equal to 1. Okay. So VA is equal to half kilonewton. So VB equal to 1 minus half. Right. So we got final values. We'll just draw it in the line that we finished. So this is my beam. This is my force. I have reactions. One reaction here. One reaction here. And one reaction here. So what are the values? So this is half. 0.5 kilonewton. 0.5 kilonewton. And this is 1 kilonewton. This is root 3 kilonewton. Root 3 kilonewton. Okay, so this is 2 kilonewton. 30 degree. Right?
What is the statistics between the concept?
So ഇതാണ് ഇതിന്റെ റിയാക്ഷൻസ്. അപ്പോൾ ഈ സപ്പോർട്ട് കൊടുക്കുന്ന റിയാക്ഷൻസ് റൂട്ട് 3 5.5 ഇങ്ങോട്ട് 0.5 ഇങ്ങോട്ട് റൂട്ട് 3 ഇങ്ങനെ. ഓക്കെ, ഇത്രയും ഫോഴ്സ് വരുമ്പോഴാണ് ഇത് ഇക്വിലിബ്രിയത്തിലാവുന്നത്. So I hope the idea is clear to you. So now you can see there is a horizontal force here. അപ്പോൾ horizontal force ഇവിടെ വരുന്നു. നേരത്തെ ക്വസ്റ്റ്യനിൽ horizontal force ഇല്ല, കാരണം നമ്മുടെ ഫോഴ്സ് വെർട്ടിക്കൽ ആയതുകൊണ്ട് horizontal force 0 ആയിട്ടാണ്. അല്ല 0 ആയിട്ടാണ്. ഈ ക്വസ്റ്റ്യനിൽ inclination ആയതുകൊണ്ട് we have this. Now we can complicate this further. Because we have to finally able to design a bridge angle. So നമുക്ക് സിമ്പിൾ ആക്കാൻ പറ്റില്ല. So let's say we have a bridge. Let's have a bridge. It has support condition as 1 and is pinned. Other than this roller, okay. Pinned and roller. So that is a simply supported bridge. Now let's say we have a car here. Okay, there's a car here. So let's say weight of the car is, let's say, 2000 kilonewton. 2000 kilonewton. Or maybe 2000 kilonewton. 20 kilonewton. 20 kilonewton. 20 kilonewton. Equally distributed to wheels. Okay. The location of the wheels are given like this. So let's say this is 3 meters. This is 1 meters, 1.5 meters, and this is, let's say, 3 meters again. Okay. So wheel the location. But 20 kilonewton is equally distributed to 2 wheels. So you have 4 wheels on top. Let's say we are cutting it, we are simplifying it. But 4 wheels got simplify it to 1 wheel. 2 wheel or 2 wheel or 4. Simplify. Okay. So within the one line diagram, then we will stop the class for the day. So let's say we have this pin support here. All this is A. We have roller support here. Okay, this is one line diagram. Okay, this is P. This is also known as one line diagram. I have 20 kilonewton is equally distributed in 2 wheels. If it 10, if it 10. So I have a 10 kilonewton here. I have a 10 kilonewton here. Okay. So this is 3 meters. 0.5 meters. 3 meters. So scale is different. I mean, it is so variable, but she did half at it. Okay. So that's a mistake that I have. So let's say I can draw that in scale also. So this is. Okay, so that means we have 2 reactions here. Vertical at A, horizontal at A. We have a 1 reaction. Vertical. Now we have to find these reactions. Okay, but now we will take this in the next class. We'll take it in this next class. I will be giving you a problem today. Any doubts? If you have any doubts, you can ask me. Otherwise, I will give you at this link. We'll doubt so we can do it.